In this video, we're going to take a look at partial derivatives. And remember that for partial derivatives, whichever variable we're not taking the function with respect to, we're going to treat like a constant. So if we're taking a derivative with respect to x, we're going to treat y like a constant. So in this first example, I have a 6x plus 2y plus 7. So when we do f with respect to x, the derivative of 6x is 6. Now remember, y is a constant, so when we take the derivative of 2y, it's like taking the derivative of a constant, so it's plus 0. And then 7 is a constant, and it's also 0. So f with respect to x is equal to 6. And then when we do f with respect to y, we're going to treat x like a constant. So 6x is a constant, and it is 0. And then 2y with respect to y, so we get 2. And then 7 is a constant, so plus 0 again. So we end up with 2. Now it's also important to remember that regardless of which derivative rule we use, we still use the rule the same way. It's that when we take the derivative with respect to a function, we need to decide which one is a constant. So here we have the quotient rule. So when we do f with respect to x, we're still going to run the quotient rule the same way. So we have 7y plus 7, the rewrite of the denominator, times the derivative of the numerator with respect to x, which is equal to 2x, minus the rewrite of the numerator, x squared plus 3. Now here we have the derivative of 7y plus 7 with respect to x. So 7y is all treated like a constant, and it's 0, plus the derivative of 7 is equal to 0, so we end up with 0 plus 0 as the derivative of the denominator with respect to x, all divided by 7y plus 7 squared. And when we simplify this, we have x squared plus 3 times 0 on the right side of the numerator, so that's going to go away. And then we have 7y plus 7 in the numerator and 7y plus 7 squared in the denominator, which means we can take away one term from each. So we have 2x divided by 7y plus 7. And now for our derivative with respect to y, we're going to start the rule the same way. So we rewrite the denominator, 7y plus 7, times the derivative of the numerator with respect to y. So x squared is treated like a constant, and we have a constant for our second term, so it's 0 plus 0 for that derivative, minus x squared plus 3, the rewrite of the numerator, times the derivative of the denominator with respect to y. So we have 7, all divided by 7y plus 7 all squared. And in this case, the left term of our numerator is the one that goes to 0. So what we're left with is negative 7 times x squared plus 3 all divided by 7y plus 7 squared. In the next example, I have f of xy is equal to 5x squared plus xy plus x squared plus y squared all squared. So here, when we do f with respect to x, the first term becomes 10x. The second term we have xy, and remember that y is treated like a constant, and the derivative of x is 1. So we're left with plus y. And then the last part of this is the chain rule. So we need to apply the chain rule. So plus 2 times the rewrite of the inside, x squared plus y squared. Subtract 1 from the exponent gives us 1. Times the derivative of inside the parentheses with respect to x. So x squared with respect to x is equal to 2x. and y squared with respect to x is equal to 0. So we're left with 10x plus y plus 4x times the quantity x squared plus y squared. And for our partial with respect to y, 5x squared is all treated like a constant, so it goes to 0. xy, and x is a constant, so we take the derivative of the y, which is 1, so we're left with plus x, plus, we still have the chain rule, so it's 2 times x squared plus y squared raised to the 1 times the derivative of the inside with respect to y. So now the x squared is treated like a constant and it goes to 0, and we have 2y. And when we clean this up, we get x plus 4y times x squared plus y squared. And in this last example, I have f of xy is equal to e to the xy. So our partial with respect to x, f of x, is equal to, and remember the derivative rule for exponential is the rewrite, so we're going to rewrite e to the xy, and now we need to take the derivative of the exponent with respect to x. And with respect to x, y is constant, and x is equal to 1, so we end up with just a y out front. And when we do f of y, the rewrite is going to be the same, so e to the xy. And now when we take the derivative of the exponent with respect to y, x is a constant, and the derivative of y is 1, so we end up with an x out front. And that's how we take partial derivatives.